This is lesson 3.4 from Accelerated Geometry, Constructing Angle Bisectors. First, we're going to review the definition of an angle bisector. It is a ray that starts at the vertex of an angle, and it divides the angle into two congruent parts. So on this angle over here, here is the vertex, and then here is the ray coming from that vertex, starting at that vertex and breaking this angle into two equal parts. It could also be a segment on that ray. So if I take a triangle now and I start at one of the vertex points of that triangle and I draw a segment in there that breaks that angle into two equal parts, then that is also the angle bisector. To construct an angle bisector, there are directions here. It has 4 steps. I am also going to do it for you after I go through these 4 steps. And down below here you can also see I have a link that you could go to see somebody professionally do this on YouTube. So here are the directions. Here is my angle, and I'm going to get a pen here. Okay, so this is my angle. The first thing you do is you stab in at the vertex and you draw an arc that crosses both sides of the angle. And then that creates 2 intersection points here and here. So from one of the intersection points, you open up your compass, any opening that you want, and make an arc inside the angle. Now keep that opening and then stab in at the other intersection spot on the side of the angle and create, with that same opening, another arc. Where those 2 arcs intersect, you connect that point to the vertex. 2 points determine a line. So there is the ray now. That is the angle bisector. So now if I put this down, you can see my screen here, and I will create an angle. Okay, first step, stab in at that vertex and swing an arc that goes through both sides of your angle. Now with the same opening or a different one, doesn't matter, stab in at one of those intersection spots and make an arc inside of the angle. With the same opening, don't change the opening, stab in at the other intersection spot and make another arc. Where those 2 arcs come together, that intersection point and the vertex are just connected, and there's a ray, and so now I have an angle bisector. Now if you know how to bisect an angle, you know some pretty cool things. For instance, I know how to make a 45-degree angle if I know how to make a 90. So remember, we do know how to make a 90-degree angle, so let's do it over here. Okay, there is a segment. I'm going to do a perpendicular bisector construction. So I open up my compass wider than halfway across, make an arc above and below. With the same opening, stab in at the other side and make arcs above and below again. 2 points determine a line. So if I connect those 2 points, they will form a line. This point here is the same distance from each endpoint, so it's on the perpendicular bisector. That's one of our conjectures. This point is the same distance from each endpoint of my segment, so it's on the perpendicular bisector of that segment. So I connect them, that's the perpendicular bisector of the segment, which means I now have a 90-degree angle. If I have a 90-degree angle, I can now do an angle bisector of the 90-degree angle. So I stab in at the vertex, swing an arc that goes through both sides of the angle. From one of those intersections, make an arc. From the other intersection, make an arc. And now connect that point to the vertex. So I now have a 45-degree angle. Okay, another angle that I know how to make is a 60-degree angle, and I know how to make that because that's one of the angles of an equilateral triangle. So if I make one side of my triangle that long, I'm going to open up my compass. That's the length of the first side. I know in an equilateral triangle all the sides are equal. So if I stab in here, this is where the second side has to start, and I know it has to be that same length. Okay, with the same opening of my compass, stab in at the other side. The third side of my equilateral triangle has to start there, and it has to be that long. So now I'm not going to finish up my equilateral triangle. I'm only going to do this side here because that is 60 degrees. Because I know a 60-degree angle, I can now bisect that angle, go across both sides, and from each intersection make an arc and connect that intersection spot to the vertex, and I have a 30-degree angle. And this one's even cooler yet because I can take that 30-degree angle, because I have two 30s now, and I'll make an arc and another arc from those intersection spots. So this is now another angle bisector. It bisects the 30-degree angle. So I now have two 15-degree angles. Now, if I know a 45 and a 90, so this is 45, this one would be 90. If I know a 60, a 30, and a 15, I can draw or construct other angles that are a combination of those. So for instance, I can do a 135-degree angle. To do a 135-degree angle, I think to myself, what is that? Take these numbers and see if I can come up with something that adds up to be 135. And I say, well, I have 90 plus 45. Those would add to be 135. So I'm going to create a straight line here, and I'm going to put a point somewhere on that line. And now I could actually copy this 90-degree angle, or it's just as easy to make one. So from that point, I'm going to make arcs on each side of the point, helping me get that helping segment. And now I'm going to do a perpendicular bisector of that helping segment. Okay, so I actually have 3 points instead of 2, so I really went overboard here, extra credit. So here's my 90-degree angle. And now I can do a perpendicular bisector of this 90-degree angle. Whoops. When you don't make the arc long enough, you just go back and make it longer. So there is now a 45-degree angle. Notice how I'm marking everything. And then for the teacher, I will say, this is my answer, 135 degrees. I can also do a 75-degree angle if I think of it as a 30 plus a 45. So I'll start again with a straight line here. I'll put a point somewhere on it. Okay, this time I'm going to be lazy, and I'm going to just copy these angles up above. So I make a 45-degree angle, which I've already done, and I already put an arc through it here when I created it. So I'm going to make that same arc over here. So I'm just copying this angle. Open up my compass as wide as the 45-degree angle is open, and come back here and say this has to be open that much also. So I'm just going to do a dotted line here because this is not my final answer here. So this is 45 degrees. And now I'm going to attach on a 30-degree angle onto that. So here's my 30-degree angle. I had my arc already go through there. So I'm going to use that same opening here. I'm going to attach it on past the dotted line. I'm going to go back. I'm going to measure how wide that 30-degree angle is open. And now this has to be open the same amount. So I stab in here and go like that. So that is a 30-degree angle. And now for the teacher, I'm going to say, hey, look, there is my 75-degree angle. So that is kind of a fun activity to create these different size angles, and you're going to be asked to do that when you do your homework. So now, let's see if I can go back to my PowerPoint. Okay. There is an investigation that you are asked to do today on page 165, investigation 1. As you do it, you're going to create a conjecture number 8. In class, you are going to do it in a group, show it to me, and then write it as with a sketch on your conjecture list. But since you're just going through this right now, I'm going to say, okay, what's happening here? They're going to tell you to create an angle, and they're going to tell you to construct an angle bisector. So this is my angle bisector. Okay, so this and this are equal to each other. Then you're going to find the perpendicular distance from a point on that angle bisector. So here's a point P. If I stab in there and go like this, and from each of those intersection spots make an arc, that is going to create this perpendicular bisector of that helping segment. With the same opening here that I just left, I'm going to come over here, make the helping segment, and from each of those endpoints make arcs, and that's going to come up to P, and that's going to create a 90-degree angle. Then they're going to ask you to use your compass to look at the sizes of these. Actually, they're going to be equal to each other. So the conjecture says if a point is on the angle bisector, then it is equidistant, the same distance, from the sides of the angle. So there is conjecture number 8 for you to draw or to write onto your conjecture list, and then draw that sketch as an example of it. So this concludes the lesson on angle bisectors, section 3.4. So you can turn off this video now.